Okay, this is a continuation of section 6.4, starting with number 16. The first video only went up through 15, so I'm going to give you a few more examples. In this particular problem, you're graphing -4 times cosine of pi over 4 over x. This is your amp. There is going to be a reflection. In other words, it's going to flip over the x-axis. This is your B value, and this is your vertical shift. So doing some of the calculations that you need to do before you can do this graph, I'm going to do period. Formula for period is 2 pi divided by B. And your B value can always be found right after the trig word, but right before the x. So right there, it's pi over 4. If you want to simplify something like this, then you leave the numerator as is, float this denominator to the top, and flip it over. That's how you simplify a complex fraction. So when you flip it over, instead of pi over 4, it'll be 4 over pi. That's now at the top and no longer at the bottom. These pi symbols cancel, leaving you with 2 times 4 is 8. Okay, so we have the period. From the period comes the jump. The formula for jump is the period divided up into 4 parts because you have a 4-part pattern for graphing any of these graphs. So period is 8, divided into 4 parts is 2. Our jump is going to be 2. So every time we plot a point, we will slide over 2 units. Okay, so now we need to recognize what the start point is. The start point is always found by thinking, what value can I put right in here so that I zero out this entire expression, which is called the argument, and that number would be 0. If you plug in a 0 right there for x, 0 times pi over 4 is 0. So you're trying to accomplish zeroing out the argument. An x value of 0 would accomplish that. The y partner that you want right there, well, just copy the equation that has the y in it. It's -4 times cosine. Remember, you're putting a 0 in there. So when you multiply 0 times pi over 4, that's going to leave you with just a 0 right after the cosine. You're purposely zeroing that expression out. That's what you can put in the calculator. When you feed this into the calculator, you just feed it in just like you see it. -4 cosine of 0 plus 3. -4 cosine of 0 plus 3. And you get -1. So you can let your calculator do that part for you. So the y partner, when you're going to use a 0 right in here, which gave us -4 cosine of 0 plus 3, results in a -1. So now we have our start point. So our start point is right here at 0, -1. You need to know what the pattern is if you want to get any points beyond that start point. So the pattern typically for cosine is up middle, down middle, dum. However, you are going to make this graph flip over because of the negative that you are seeing right out here in front of the amp value. So the way you make a pattern, take the graph and flip it completely over, is you switch the U's to D's and the D's to U's, so that when you were supposed to be going up, you're now going to be going down. When you were supposed to be going down, you are now going up. The M's for middle, they stay the same. Make sure that you are using the flipped pattern, not the original, but you can only, most people have to think about what the original pattern is so that they can rewrite it with the U's and the D's switched. Okay, so we won't be using that anymore. So we have our start point, and that start point that we just plotted, the 0, -1, that has to do with the very first letter, which is a comment that I've made in all the graphs that I've done in this section. That first point has to do with the first letter. So that 0, -1, you're at the lowest level that you can possibly be at, also known as the downward shelf. And so right then and there, I would install the other shelves, the middle shelf and the upper shelf. The shelves are spaced out by virtue of the amp. So the amp in this problem is 4. So that means there's a spacing of 4 units between the shelves. So if I'm at -1, I have to go up to the x-axis and then 3 more to be at the next shelf, which is called the middle shelf. It goes down, middle, upward. Move up another 4 spaces. You're at 3, you're going to go all the way up to 7. And that's going to be your upper shelf. Okay, now you can do the rest of the points. So far, we only had the start point, but we needed to know what the jump was. We needed to know what the pattern was. We needed to know what the start point was so that we can make progress in the graph. Okay, so now we're going to look at the second letter. We've already done the 0, -1 in the downward level. Now we're going to, the jump, remember, is 2. Slide over 2 spaces and do what the pattern says, which is to graph a point at the middle level. Okay, you slid over 2, you went up to the middle level. Slide over 2 again. This time go to the uppermost level. Slide over 2 again. This time come back down to the middle level. Just like you're playing Pac-Man, that ball is bouncing. And then, slide over 2 and all the way down. So that's what you're doing. You're going from the lowest level to the middle to the upper level. So there's 3 positions on the way up, 3 positions on the way down. Never skip over any of these levels. If you want to come over here, you don't need to look at the pattern anymore. You're at rock bottom here. You cannot go any further than the downward shelf. So you need to start moving up. Every time you're going to plot a point, slide over 2 units and now start coming back up. You're at the downward shelf. Next shelf that you can possibly be at is the middle. Slide over 2 units and all the way up. Now you're as high as you can go. Start coming down. So slide over 2 to the middle. Slide over 2 all the way down and connect those dots. Oops, missed that one. Okay, so that's problem number 16. Problem number 17. You want to be careful about doing these graphs if they're not in standard form. So be very aware of the theorem outline that I gave you. You should have the amp in the front, then the trig word, then the b value right in front of the x expression. It's either going to have a horizontal shift or not. If there's a number inside the parentheses with the x subtracted or added to the x, that would be a horizontal shift. We haven't seen many of those. And then the vertical shift is a number that is not bound within any kind of a parenthesis. It's either added or a subtracted number. This equation happens to be written, it's not in standard form. So you should rewrite it so that you don't mistakenly think that that is the amp just because it's the first number. So let's rewrite this in standard form as the theorem page gives. The number in front of the trig expression is your amp. The 4 is your b value. Okay, that's your amp. This is your b value. And then that +4, that's your vertical shift. Get it in the right form, then start graphing. Okay, so now when you continue now, we usually do the period first, which for sine or cosine starts off with 2 pi divided by your b value. B value is right there, right after the trig word, but right before the x. So 2 pi over 4, that gets you pi over 2. If you want to figure out what the jump is, then you need to use the formula for jump, which is period divided into 4 parts. So this would be pi over 2 divided by 4. And I'll continue that down here. Division is the same thing as multiplication. So I wrote pi over 2. Changing this into multiplication, division is the same thing as multiplying by the reciprocal, which is that float and flip that you keep seeing me do when I want to simplify a complex fraction. So this, let me write this a little bit clearer. So that's going to end up being top times top would be pi. Bottom times bottom would be 8. That's going to be your jump. Okay, so when you go to do this problem, you're going to have to alter the x-axis because they've already kind of shoved in their own homemade numbers there rather than allowing you to design the x-axis yourself. On test day, you're going to be designing the x-axis yourself. But if you're going to be working with what they've given you here, then you could kind of just renumber it. I think in my math lab, you can actually renumber it yourself. So I believe that's what I'm going to do. I'm going to call this pi over 8, 2 pi over 8, 3 pi over 8. Get rid of that. I'm counting with respect to my jump. So 1 pi over 8, I'm not going to cram numbers in there because they'll just, get all over each other. So 1 over 8, 2 pi over 8, 3 pi over 8, that would be 4 pi over 8. This would be 5 pi over 8, 6 pi over 8. This would be 7 pi over 8. So, sorry about that. My dogs are going nuts. So this is negative 1 pi over 8, 2 pi over 8. This would be negative 3 pi over 8. I'm not going to use their numbers because that just makes it inconvenient. 4 pi over 8, negative 5 pi over 8. 6 pi over 8, negative 7 pi over 8. Okay, so there it is renumbered. And now I'm going to do my start point. I haven't done that yet. So the start point is when you're going to zero out the expression that's right here. So putting a 0 right in there, that would zero this out. You're always trying to do that, to zero out the argument. So you're putting in a 0 for x, and then you're letting your calculator do the work to get you the y value. So copying this equation for y would be negative 2. Sine of, you know that you're putting a 0 in there. That's going to make that whole thing go to 0. That just makes it easy to calculate the y value. If you just set your sights on always zeroing out that argument. Now, if you want to go and enter this in your calculator, you just literally put it in just like that. Negative 2 times sine of 0 plus 4. I can calculate this in my head, and you'll be able to do that soon also. So this is just going to be 4. Put it in your calculator, and you'll get the same answer. All right, so then you can start plotting. So you can go 0, 4. That's going to be our start point. Don't forget that the start point is all about the first letter of the pattern. The pattern for sine is mum-d. However, just like in problem number 16, this is a flipped pattern because notice that when we rewrote the problem, and let me see if I can get this is what it looked like when we rewrote it. See that negative 2 that's out there? That means you're going to reflect over the x-axis. Okay, that is nothing more than changing the U's to D's and the D's to U's. The M's stay the same because you can't change what middle means, but you can change up to down and down to up, which will make the entire graph flip over. So far I have, if I was you, I would cross out the old pattern. You should always be looking at the original pattern first and then flipping the U's and the D's so that it reflects. So this M that you see right here, that's all about our start point. The start point at 0, 4 is at the middle level. So label that right away as soon as you know what level that start point is by looking at the first letter of the pattern. Then you can put the other shelves in place. And the shelves are spaced out by whatever the amp is. The amp in this problem is 2. Amp is without the negative. So you're going to go up 2. And then you're going to go down 2. So now I have all 3 shelves in